The ruins of Viking settlements in Greenland and northern Iceland confused archaeologists for decades. These were not temporary shelters. These were permanent homes that endured Arctic winters, hurricane-force winds, frozen ground that shifted year after year, and generations of fuel scarcity. Yet inside these structures, evidence showed stable warmth, dry interiors, and long-term human comfort. This wasn't luck, and it wasn't brute insulation. It was engineering born from survival, refined through observation, and perfected without textbooks. What makes this story uncomfortable for the modern world is that early 20th century engineers tried to recreate these homes and failed. Their designs collapsed under moisture, rotted from mould or hemorrhaged heat. The Vikings had solved problems that industrial materials could not. They didn't fight the environment, they worked with it. And the lessons they left behind still matter now more than ever. If you're here for hard survival knowledge rooted in history, take a moment to like this video, share it with someone who respects old world engineering, comment if you've experimented with traditional building methods, and subscribe to WARFRONT Survival for deep dives into forgotten technologies that still outperform modern systems. Now, let's get into why Viking homes survived where modern houses failed. The Viking understanding of cold was dynamic, not static. The Arctic is not simply cold air pressing against walls, it is a moving system. Wind scours structures. Snow insulates, then suffocates. Frozen ground heaves and settles with seasonal rhythm. Most modern houses are rigid boxes designed to resist motion. Vikings knew this approach would fail. Instead, they built structures that could flex, breathe, and regulate themselves. Viking longhouses were never airtight. That was intentional. Cold air was allowed to enter slowly at the base of turf walls, while warm air from the central hearth rose naturally and exited through controlled gaps in the roof. This passive airflow stabilized interior temperatures and prevented condensation. Moisture never had a chance to pool, which meant mold could not take hold. Later, European settlers sealed their homes too tightly and paid the price when rot and dampness destroyed entire settlements. Layered walls created insulation, airflow, and resilience at once. The walls of a Viking longhouse were systems, not barriers. A deep stone foundation anchored the structure and absorbed heat during the day, releasing it slowly overnight like a thermal battery. Above that, layers of turf were stacked with care, alternating direction and density. Each layer trapped air while allowing slight movement, which prevented cracking as the ground shifted. Between turf layers, Vikings added dried grass, straw, and sometimes seaweed. These materials created microchannels that allowed slow air circulation without drafts. This balance of insulation and ventilation is something modern builders struggle to replicate even with synthetic materials. The result was a wall that stayed warm, stayed dry, and lasted for decades. The roof was heavy by design, not a structural flaw. Modern architecture favours light roofs that shed snow quickly. Vikings went in the opposite direction. Their roofs were low, thick, and weighted with turf and moss. This mass absorbed heat from the interior and released it slowly, smoothing temperature swings across day and night cycles. The curved shape reduced wind noise and pressure while preventing sudden heat loss. Even when the central fire burned down to embers overnight, interior temperatures remained stable enough for sleep and daily life. This wasn't luxury. It was survival efficiency refined through generations. Why 20th century engineers couldn't simply copy the method. During the 1930s and 40s, Scandinavian engineers revisited Viking building techniques while designing Arctic research stations and military shelters. They found that structures based on turf, airflow principles required drastically less fuel, stayed dry without mechanical ventilation, and remained quiet and thermally stable under extreme conditions. These designs challenged the assumption that energy input had to increase with environmental severity. When traditional fuel-dependent buildings were outperformed by earth-integrated designs, the research quietly disappeared into civil defense and military archives. The reason was simple. Systems that need little fuel threaten industries built on constant consumption. How Viking principles can still be applied today. The first lesson is integration with the earth. A structure partially set into the ground benefits from stable subsurface temperatures year-round. Even lowering a third of a building's volume below grade can cut heat loss dramatically. The second lesson is layered mass, not single material insulation. Soil, sand, straw, and natural fibres layered in alternating orientations trap air and reduce thermal bridging. Heavy roofs store heat. Light walls bleed it. The third lesson is controlled airflow. A small vent near the floor and one near the roof peak allows natural convection to regulate temperature and humidity without fans or power. When calibrated correctly, the system self-adjusts based on interior heat levels. These principles work not only for homes, but for root cellars, workshops, animal shelters, and off-grid survival structures. The goal is balance, not force. Why this knowledge still matters. Viking environmental engineering was never written down as theory. It was learned by watching what failed and refining what endured. Modern science has confirmed its efficiency, yet it was dismissed for decades as primitive. In an age of energy insecurity and fragile infrastructure, these old solutions offer resilience without dependence. The past is not nostalgia. It is instruction. If this deep dive into Viking survival architecture gave you something useful, subscribe to WARFRONT Survival. Share this with someone who values real history and comment below with topics you want uncovered next. Forgotten knowledge still keeps people alive. We're here to bring it back.